The Great Pyramid of Giza is widely understood as an ancient tomb, but for alternative historians and esoteric mathematicians, it is an unresolved mathematical equation. Theorists like Dan Winter and mathematician Ralph Abraham propose an architectural hypothesis about its construction. They argue the pyramid's dimensions were deliberately engineered to perfectly encode a geometric equivalence between two fundamental constants, the golden ratio, or phi, and pi. This 3D wireframe demonstrates their claim. Divide the pyramid's base perimeter by its central height, and the result is 1.57, argued to be exactly pi divided by 2. Simultaneously, the slope of the outer faces encodes phi, the golden ratio, at 1.618. If true, the builders successfully executed a unified geometric theory, linking two entirely distinct classes of numbers in a single structure. Such an achievement rewrites the history of ancient mathematics. It forces us to ask whether the builders possessed advanced, lost mathematical knowledge, or if we are simply projecting modern patterns onto ancient stone. Mainstream mathematicians reject this hypothesis entirely. To the academic consensus, equating these numbers is an absolute impossibility. This debate is where the flawless, infinite realm of pure mathematics violently crashes into the messy reality of physical space. Pure number theory dictates that phi and pi belong to completely different mathematical categories. They cannot share the simple algebraic relationships required by the pyramid hypothesis. To bypass this deadlock, Ralph Abraham proposes what we will call Answer 3, a philosophical framework attempting to reconcile this impossible math with the physical measurements of the artifacts themselves. We'll apply the Gelfond-Schneider theorem to dismantle the algebraic claim. Then we will examine how the physical margins of measurement create an epistemological illusion. This is a conflict between the absolute rigidities of mathematical law and the inherent fuzziness of the physical universe. To understand the math, we have to define an algebraic number. This is any number that can act as the root of a non-zero polynomial equation using only integer coefficients. This chart displays a standard Cartesian plane graphing a simple polynomial, y equals x squared minus x minus 1. The point where this curve perfectly intersects the x-axis gives us phi. The golden ratio is mathematically born directly from this finite integer-based equation. A transcendental number, however, is defined by its inability to do this. It can never be the root of any rational polynomial. Pi is the most famous transcendental number in mathematics. By definition, it completely escapes the algebraic rules that construct the golden ratio. No matter how many integer-based polynomial equations you build, or how complex they get, the resulting curve will never naturally intersect exactly at pi. This creates an impenetrable classification wall. Phi is algebraic, pi is transcendental. Because phi is anchored to finite algebra and pi is completely unbounded, attempting to equate them perfectly in a geometric shape is like trying to translate a concept into a language that lacks the vocabulary to express it. Despite this classification wall, esoteric theories often suggest that pi might equal a specific power of phi, perhaps pi equals phi squared, or some similar algebraic configuration. This graph maps a specific polynomial used to test that exact relationship, w to the fourth plus 2w cubed minus 2w squared plus 2w plus 1. Dropping pi onto the x-axis, the irreducible curve completely misses it, failing to capture pi as a root, proving they cannot be linked. The interaction between these classes of numbers is governed by the Gelfond-Schneider theorem. The theorem states that if you raise an algebraic number like phi to an algebraic power, the result is indeed a transcendental number. But you cannot use this mechanism to map a simple polynomial relationship to one specific pre-existing constant like pi. The mathematical proof is settled. Statements claiming pi equals a multiple of phi or pi equals phi squared are false. For the academic consensus, the debate ends right here. While the formal disproof is absolute on paper, it completely fails to explain why the physical measurements of the pyramid remain so stubbornly persuasive to anyone holding a tape measure. The perfection of pure math exists in a vacuum. Physical construction happens in the elements. Physical artifacts have uneven edges. They suffer from thousands of years of erosion, settling, and structural shifting. In archaeology, this introduces error bars, a required tolerance for measurement uncertainty. Look at this 2D cross-section. 2 divided by pi is roughly 0.6366. Mapping this target onto the pyramid requires accounting for physical wear. Because reality is fuzzy, a range of numbers technically fit. Depending on where you place instruments on the weathered stones, both the pi-derived ratio and a phi approximation land perfectly inside the margin of error. Mainstream archaeologists conclude the builders simply used an approximation known as Egyptian pi, rather than the exact transcendental number. Esoteric theorists view this entirely differently. To them, the fact that both constants fit inside this physical overlap is intentional, a deliberate encoding of higher geometric knowledge. If you treat the exact modern measurements as flawless, the fit becomes a massive numerological coincidence. Finding both numbers closely represented in the same physical space does not mean they are algebraically equal. The allure of the pyramid isn't located in mathematical perfection. It lives in its physical imperfection, creating a margin of error just wide enough for human imagination to insert impossible math. Ralph Abraham approaches this margin of error through a concept called sacred periodicity. This concept looks past the rigid rules of linear algebra and instead searches for geometric recurrence in the natural world. This animation shows the pyramid's proportions morphing directly into a Fibonacci spiral, tracking the limit toward phi. Proponents of sacred periodicity link the specific dimensions of the Great Pyramid to macroscopic structures, like planetary orbits and galaxies. They argue these identical ratios also govern the microscopic world, serving as the biological blueprint for structures like the DNA double helix. This framework requires the pyramid to act as a sacred periodic object, a physical bridge spanning atoms, planets, and transcendental numbers. This esoteric approach abandons the need for standard algebraic proof. It asserts that the physical universe inherently links phi and pi through biology and architecture in a way that our equations simply cannot capture. The Great Pyramid remains the ultimate test case for this tension. This brings us to answer 3, Abraham's conclusion that the structure is a uniquely sacred artifact, specifically because it forces a confrontation between pure math and physical reality. This split screen visualizes the core problem. Left, the rigid equations of the Gelfond-Schneider theorem. Right, the physical textured pyramid and DNA, borders oscillating due to measurement tolerance. Pure linear algebra proves these numbers are completely isolated, yet the physical world effortlessly merges them. Our current mathematical systems map perfectly to pure theory, but they struggle to assign concrete meaning to physical approximations. Because of this, the academic consensus will forever view the pyramid's dimensions as a statistical fluke of measurement. Answer 3 is not a mathematical solution. It is a philosophical one. It suggests that human linear algebra is simply too rigid to describe the holistic, intertwined geometry of the natural world. So, does the Great Pyramid actually encode transcendental numbers? The first option is that it is nothing more than a numerological accident, born entirely from the fact that crude ancient stones carry wide measurement tolerances. The second option is that it is an intentional, physical manifestation of sacred periodicity that our standard algebraic formulas are unequipped to process. We are left with an unending cycle, trying to force the absolute perfection of pure math into the weathered edges of a physical universe. The Great Pyramid stands not as a solved equation, but as an architectural mirror. It reflects either our desperate desire for hidden cosmic codes or the cold, absolute rigidities of pure numbers.